All right, in this video, I'm going to cover the section 8.2 and 8.3. So before jumping to the lecture, please make sure that I'm strongly suggest that you read at least the examples in the PowerPoint lecture slide. Okay, so this is really important. And then also before the so yeah, we'll see in this class. I'm gonna solve a lot of problems. I mean examples, but you need to fully understand the procedure of the hypothesis test, which I covered 8.1. So you need to fully understand 8.1. Okay. So now today in 8.2, we're gonna learn about hypothesis test, the about a proportion. Okay. So based on the using the sample data and sample proportions. Okay, so and then we gonna get conclusion about the claim about the population proportion. Okay, so we learned the about the test statistic and the p-value, right? And then the alternative hypothesis, and then their hypothesis h sub 1, h sub 0, right? So now, so you see, definitely we gonna use the calculator. Okay, so I'll show you. So we jump into the example. Okay, so let's say test the claim that less than 10% of subject treated with Symbicort, uh, Symbicort for asthma experience headaches at the zero point zero 0.05 significance level. So from here, first sentence, we can see that the claim that less than 10% of subject. Okay, so means that P is less than zero point 0.1, right? That's the claim, right? So now from there, we can figure out the alternate H sub 1 and H sub 0. And then alpha is zero point zero 0.05 is given, right? So from the alpha, we can figure out critical value, right? Now, in a clinical trial, 18 out of 277. So 277 is sample size. 18 is what? 18 subject experience headache. So P hat gonna be 18 over 277. Right. So anyway, see, let's figure out all the parameters we need. Okay. So now, first we need to figure out the null hypothesis and then alternative hypothesis, right? So let's figure out give me a second, the alternative hypothesis. So the claim is this. Claim is P is what? Less than. Okay. So give me a second. P is less than zero point 0.1, right? So A sub 1 gonna be P is less than 0 point 0.1. How come? Because see, the P is less than 0 point 0.1. What the opposite of that inequality is P is greater than or equals, right? So P is greater than or equals 0 0.1, right? But since this inequality contain equal sign, right? So we gonna we choose the see that key minus alternative hypothesis should not involve the equal sign. So we choose P is less than zero point 0.1. So it turns out that alternative hypothesis H sub 1 is claimed. Now then null hypothesis always what? P equals zero point 0.1, right? So H sub 0 is not is equals. So one is a P is equal to 0 0.1. Okay. So now next one, step 1 and step 2, step 3, that's what we have done. Okay. And then step 4, we figure out the test statistic and then the p-value, right? But the all we know is what we need to figure out the p hat. Okay, because eventually we're gonna use a calculator. Okay, so p hat is a p hat. Okay, p hat is that's the sample proportion 18. out of 277. Okay, then that's enough. So you don't have to figure out the test statistic p-value by hand using those formulas. Okay, so because calculator will figure out those values. Okay, so now I'll show you how to use calculator to figure out the uh, the hypothesis, how to do a hypothesis test. Okay. All right. So here, first of all, what you're gonna do, you need to go to the stack. Okay. So press stack, and then there is 3 tab right there. So we go to the test. Okay. So the z test, t test, in the 2 sample z test, but we need one proportion z test. Okay. So that's the hypothesis test for proportions. Okay, let's go there. And then p sub naught, I mean p naught means the value uh, from the h naught. Okay, so null hypothesis h naught, h sub 0 equals that was h sub 0 was the p equals 0.1, right? So now that 0.1 is p naught. Okay, so p sub 0 is 0.1, and then the x is a number of the subject or object. In this example, the experience headache. Okay, so it's 18, and the n is a sample size 277. And then this one, the proportion is not equal to p0 or less than p0. Okay, that's the from the h sub 1 alternative hypothesis. So we got the what p is less than 0.1, right? So we choose that inequality. P is less than, proportion is P, okay? P proportion is a population proportion, less than P sub 0. What was P sub 0? 0.1, right? It makes sense. We figured out that in alternative hypothesis, P is less than 0.1. Here, the P is a population proportion less than 0.1. So in calculator, P sub naught denote the 0.1, right? So now we can use the calculator draw. Well, let me use draw, okay? Draw. Then we're gonna get this the sample distribution with that shaded region right there. So that's a z right there, negative 1.9427. That's the test statistic. And then p equals, that's the p value actually, 0.026. So we got the left we apply the left tail test, right? Because the alternative hypothesis is less p equals less than 0.1. Okay. So and then the conclusion is what p value, since p value is less than alpha 0.05. Okay. So okay. So let me give me a second. Let me draw that one in the scratch paper, and then I'll just continue to explain the solution. Okay. All right, so this is the, I just copied the graph of the sampling distribution. Actually, this is standard normal distribution. So here, the p equals 0. Okay, so what's p? P is a population proportion, okay? So that's the population proportion. Okay, so now p hat is the sampling proportion, okay? This is the standard normal distribution. Okay, so now the alpha is 0.05. We use a left tailed test. Okay, this is left tailed test. Okay, so what is this? Yeah, so I covered this one in 8.1. So please watch the video or look at the PowerPoint lecture slide of 8.1. So left tailed, we apply left tailed test because the H sub 1 alternative hypothesis was p is less than 0.1, right? Because of this. So now then alpha is 0.05. That's alpha is the area, okay, under the graph of normal distribution, which means the probability that what the population proportion is the extreme. Okay, so then since alpha is 0.5, we can find out the z score corresponding to that area 0.05, right? Using the inverse norm. So in the calculator, you don't have to find out this, but let's find out. Okay, so then we go to distribution. Okay, so press second, and then press VARS variables. Then you see inverse norm right there. Okay, so area 0.05, and then mu 0, and the sigma 1. Leave it, then click. You got the negative 1.64 approximately, right? So this is a negative 1.64. Okay, now in the hypothesis testing, one proportion z-test intrinsic function in calculator, we figured out p-value, which is a 0.026, and then test statistic. This is test statistic, okay? Uh, okay. So now then negative 1.9427 right there. So here, if p-value is less than alpha, yeah, so in this case, p-value is less than alpha, right? Okay. So what that means, the test statistic is what? Test statistic, we got this one from the sample proportion p hat and 0.1 from the claim, right? P, okay? Assuming this, and then we assume that the null hypothesis is true. Okay, so P is a 0.1. We assume that the population proportion is a 0.1. Assuming this, okay, using the sample proportion, we got the test statistic, and this is belong to the what? Extreme value, significantly low, right? So that's the meaning of this. So that what we reject the H sub 0, null hypothesis. So this we reject that claim, that H sub 0 hypothesis, and then H sub 0 is a claim. Then the conclusion is there is sufficient evidence to reject the claim. Okay, so doing this, we have 4 cases. Okay, for every problems, um, for all problems in the chapter 8, to get a conclusion, the conclusion can be classified as 4 cases. Okay, PBL is less than alpha, and then H1 is the claim. Then there is sufficient evidence to support the claim. Okay, because PBL is less than alpha means that we reject the H sub 0, and the H sub 1 is the claim. Then there is sufficient evidence to support. Okay, so now the third case is this: if PBL is greater than alpha, PBL is greater than alpha is what? Test statistic is somehow right there in the left tail test, okay? In this case. So now the and the H sub 0 is a claim, then there is not sufficient evidence because we fail to reject the H sub 0 because PBL is greater than alpha. So there is not sufficient evidence to reject, okay, the claim. And then PBL is greater than alpha, then we fail to reject. So in those two cases, we reject the H sub 0, okay? And then the other two cases, PBL is greater than alpha, then we fail to reject H sub 0, okay? And then the H sub 0 is the claim. Since we failed to reject H sub 0 and the H sub 0 is a claim, then there is not sufficient evidence to reject, okay? And then we failed to reject the H sub 0 and the H sub 1 is a claim, then there is not sufficient evidence to support. Okay, that is in the the lecture note. So please look at that. Okay, so the in here, let's back to the my lecture note. So now you see here, I summarized the procedure of the hypothesis test. Okay, step 1 to step 7, right there. Okay, and then in the specific example, we applied that one, right? It's a left tail test. Okay, depending on the H sub 1. Okay, so now this here we got this. The statistic Z was negative 1.9427 and p-value is the 0.026. Okay, so conclusion is what there is. So here, what h sub, yeah, definitely p in this example, p value is less than alpha, right? So what's alpha, by the way? Alpha is what, 0.05, right? Okay. So now, and then p value is less than alpha, and then h sub 1 is the claim, right? So there is sufficient evidence to support the claim. Okay. That what? 10% of subject. Seen by a court for asthma experience, headache. So at the 0.05 signal level. Okay, that's the conclusion. So now all the examples, all other examples are similar to what I did in this example. So let me solve one more problems. So now let's see. Let's see next example. In a survey of 510 randomly selected adults, 132 said they would be comfortable in a self-driving vehicle. So use a 0.05 signature level to test the claim that more than a quarter of others feel, it should be feel, right? Feel comfortable in a self-driving vehicle. Okay, so now the here what we need to figure out is what h sub 0, h sub 1, right? So it's first one, claim. Claim is the what? P is greater than, right? More than one quarter is a 0.25, right? Okay. So now, and then h sub 1 gonna be p is greater than 0.25, right? And then h sub 0 is p equals 0.25. Why? Yeah, did you figure out that why we h sub 1 is this? Because p is greater than 0.25. The reverse, I mean, the reverse of the inequality is what? Less than or equals, right? And the opposite, I'm sorry, the opposite of this one is less than or equals. Since the less than or equals, the opposite of that inequality contains equal sign, but h sub 1 should not include the equal sign, so we choose claim p is greater than 0.25. Okay, and the null hypothesis is always p equal, the equal sign must be included. So now the x is what, 132, and then n sample size is 510, right? Okay, and the alpha is 0.05. Okay, now using the calculator, okay, so we can figure out the p-value and then a test statistic, right? So now see, we go to the test stack. Okay, we go to the stack. So we go to the test and then we choose one proportion z test. Okay, so p sub n is a 0.25 from null hypothesis. Okay, so x value is 132 and then n is 510, right? And the proportion is what? P is greater than 0.25, right? So we choose that inequality. Okay, let's see. And then you can just calculate, okay? But let me, I'll prefer to draw the sampling distribution with the shade region, okay? So here is g cost test statistic is 0.4602, and the p-value is 0.32. Okay, so now the from here, since the p-value, okay, is greater than p-value is greater than alpha 0.05, right? Okay, now why we got the right so shaded region on the right side, right? Because the alternative hypothesis, well, p is greater than 0.25, so we have to apply the right tail test. Now, since the p-value, which is 0.3227, is greater than alpha 0.05, so p-value is what, greater than alpha, and then h sub 1 is the claim. So there is not sufficient, conclusion must be what? There is not sufficient evidence to support the claim. Okay, you see? Because the what? PBL is greater than alpha means that what? We fail to reject the null hypothesis, H sub 0. Okay, keep in mind is we got this one based on the under the assumption that H sub 0 is true, which means that population proportion is 0.25. Okay, so then there is not sufficient evidence to support the claim that more than 0.25 of more than 25% of adults feel comfortable in a self-driving vehicle. Okay, so now the all right, let's see these examples. So test the claim that 88% of all airline flights are on time at the 0.1 significance level. In a random sample of 48 flights, 38 were on time. So now the claim is what the P is 88%. Okay, so 0.88, right? Now then H sub 1 must be what? So it should be opposite of claim. So it's, P is not equal to, I don't know how to write the symbol, is not equal math symbol in a Microsoft Word. So we'll just say is not equal to, is not equal to, okay, 0.88, okay. So now then H sub 0, that is what? P is equal to 0.88. So now in this example, null hypothesis is the claim, right? All right, so now then X is the 38, right? So number of the object, the satisfying the object were on time, okay? So now the 40n equals 48, which is sample size, okay? And then our alpha is the 0.1, okay? So we use calculator. So here's calculator. Then we go to the stack. Wait a second. Stack, the test, and the one G test. Okay. So the interesting is this. I mean, in this example, since the claim is P equals 0.88, right? And the alternative hypothesis P is not equal to 0.88, right? So I missed the writing P in the alternative hypothesis. Give me a second. P. Okay. So then we have to use the the both tail test, right? What it means is we apply this one. So here, now we're gonna once we find the p-value, we have to take half. Take the half of p-value. So that one, the shaded region colored by red, that's actually alpha over 2. This is also alpha over 2. Okay, so half of p-value is less than half of the alpha, then we reject a sub 0. Okay, keep in mind this. All right, back to the calculator. So p sub 0 is 0.88, and then x is the 38, and then n is 48, and then we choose population proportion is not equal to p0 from the h sub 0. Okay, so we draw. Okay, So now you see the test statistic is negative 1.8833 and the p-value is 0.0597. Okay, so we take a half of p-value. So we got the 0.02985. Okay, so we compare that value with the half of alpha. Alpha is a 0.1. So a half of alpha is a 0.05, right? So definitely 0.029 is less than 0.05, right? So half of p-value is less than half of half of alpha, and then what H0 is the claim, right? So it's the first case. Then there is sufficient evidence to reject, okay, the claim, right? So since the p-value half of p-value is less than half of alpha, okay. So now then, so we reject the null hypothesis. It means that yeah, so p equals 88% of all airline flights are on time. Okay, we rejected that claim based on the that evidence. Okay. So the conclusion, I mean, test statistic is what was this? Give me a second. That was the negative 1.883. Okay. The p-value is the 0.0596. Okay. So anyway, it's a conclusion. There's what there is sufficient evidence to support. Oh, evidence to reject, right? Claim. Okay. Claim that 88% of all airline flights are on time at the 0.1 significance level. Okay. So that is the this section 8.2. Okay. So now we move to the 8.2, testing a claim about mean when sigma is known. Okay. So in the sigma unknown, since sigma is unknown, we cannot use the standard normal distribution. Instead of that, we use a test t distribution. Okay. So this is how to find this formula for finding the test statistic. Okay. The p-value can be probability of the that t-value. Okay. So that requirement, the sample is a simple random sample, and that the population is normal distributed, or the sample size is greater than 30. Okay. So see example. So use a 0.01 significance level to test the claim that the mean body temperature is 98.6 degree. So that's a claim. Claim is this: the mean body temperature is 98.6. And then a sample of 106 body temperatures measured at midnight had a mean of 98.2 and standard deviation of 0.62. So in this problem doesn't give us this population standard deviation sigma. Okay, so we gotta use t distribution. Then what are you gonna do? So we need figure out the h sub 0, h sub 1, right? First one, claim is what? Mu. Let me just let me use okay. So let me use a mu. Okay, mu is 98.6. Okay, that's a claim. Let h sub 1 gonna be what? Mu is not equal to let me use this one. Mu is not equal to 98.6. Okay, and then h sub 0 mu is equal to 98.6, right? Because the I told you alternative hypothesis should not include the equal sign, so mu is not equal to 98.6. We have two choices: claim and the opposite of claim. So claim is mu equals 98.6. Opposite of claim is what? Mu is not equal to 98.6. Since the h sub 0 alternative hypothesis should not include equal sign, you have to choose opposite of the claim in this example. And then the null hypothesis is always mu equals, okay, in this example, can be equals the 98.6 is mu zero, actually mu sub zero, okay, so mu sub zero. And then the one of the next one is the sample size n and x bar, right? Sample mean x bar is a 98.2, and then sample standard deviation, let me say STD, that means the standard deviation is a 0.62, and then sample size is 106. Okay, so now we're going to find out test statistic and then the p-value using those information using calculator. Okay, all right, in the calculator, so we go to the stack and then test. Okay, and we use t-test. Okay, not z-test. Okay, because the sigma is unknown. Sigma is known, that we use a z-test, but we use the test. So test means here test stand for in calculator. Test stand for the hypothesis test. Okay, so we choose t-test, and then there are two options: data using input is data or stat. Okay, because in the example the sample statistics are given, right? So we just stacked. So mu zero, mu sub zero. Mu sub zero is the what value in the h sub zero. Okay, lower hypothesis 98.6, 98.6, and the x bar sample mean is what is 98.2, right? And then as x sample standard deviation is 0.62. Sample size is 106. Okay, and then what was the inequality in the alternative hypothesis is not equal to, right? So we use this, and then we draw. Okay. So now, as you can see that what p-value is almost zero. Is okay. So let me test, and then let me just calculate instead of draw. You see that p e99 is 10 to it means a 10 to the 99th power. So it's a really small number, right? Okay. And what was ARPA? ARPA is the what a 0.01, right? The p is a really small number, right? So as you can see that p value definitely less than ARPA, right? Okay. Let me see that. But actually, what since what the alternative hypothesis mu is not equal to 98.6, because not equals that inequality is applied. So we use the both tail test, right? Okay, so right and left both tail tests. So we have to take what take half of the p-value and then compare the half of ARPA. Since in this example ARPA is 0.01, so half of ARPA is 0.005. But definitely, half of the p is you know less than this value, and then definitely then that half of p value is less than 0.005, which is half of ARPA. So half of p value is less than half of ARPA. Okay, and then h is 0. Okay, so you see is the what the claim, right? So there is sufficient evidence to reject. Okay. All right, back to the lecture note. So the conclusion is what there isn't sufficient evidence to reject the claim that the mean by temperature is 98.6 degree. I mean, so it's you may think that yeah, it sounds weird. I mean, something wrong because actually mean by temperature is 98.6 is it seems right. Yeah, it's the mean by temperature is 98.6. I mean, in common sense, the in general 98.6 is a mean by temperature, right? But what's the wrong? Maybe the sample is not selected randomly in this example. Okay, so because the example didn't mention about sample is a random, okay, sample, okay, and then significance level is too high, okay. So, but based on the sample, we conclude that there is sufficient evidence to reject the claim. Okay, so let's see other problems. So, yeah, we'll see. When 40 people use the Weight Watcher diet for 1 year, and their mean weight loss was 3.3 pounds. So, and then the standard deviation was 4.9. Okay. So use a zero point zero 0.01 significance level to test the claim that the mean weight loss is greater than point. Yeah, I think is the was a typo right there. So give me a second. Yeah, it's the zero is right. Okay, it's not typo. And based on these the result, does the diet appear to have statistical significance? Does the diet appear to have practical significance? So let's see. So here, let's see. First one, what's the claim? Claim is the what? Mean weight loss. I mean, let's say, we use mu, right? Mean weight loss. So the claim that the mean weight loss is greater than zero. So greater than zero, right? And then h sub 1 gonna be the what? The opposite of the claim. Mu is less than or equals, but there's equal sign included, so we drop it. So mu is greater than zero. That's gonna be, I mean, the original claim gonna be h sub 1, and then h sub 0, the mu is equals 0. Okay, and then the sample mean is the what? Weight loss was 3, right? 3 pound. Sample standard deviation is the 4.9 pound, and then sample size is 40. Okay, and then alpha is 0.01. Okay, so now the what's the statistical significance? What's the practical significance? We learned in chapter 1, but let me tell you again. So statistical significance, give me a second. So you see that statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. So for example, getting 89 girls in 100 random births is statistically significant because such an extreme outcome is not likely to result from random chance. Okay, now you see. So statistically, I mean, the probability that the event occurred is 5% or less. I mean, less than or equals 5%. Okay, which means it's less than or equals 0.05. And then practical significance is, yeah, so it is possible that some treatment or finding is effective. Okay, so the statistic show the effectiveness of the treatment or something. But in common sense, might suggest that the treatment or finding does not make enough of difference to justify its use or to be practical. Okay, so the example is this example to statistical significance versus practical significance. Care Industries once supply a product named a gender choice that supposedly increased by chance of a couple having a baby with a gender that they desire. In the absence of any evidence of its effectiveness, the product was banned by the FDA as a gross deception of the consumer. So suppose that the product was tested within 10,000 couples who wanted to have baby girls, and the result consists of 5,200 baby girls born in the 10,000 births. This result is statistically significant because the likelihood of it happening due to chance is only 0.003. It's definitely less than or equals zero point 0, you know, 5%, right? So chance doesn't seem like a feasible explanation. That's the example of statistical significance. And then next one, that 52%, the give me a second, the other one example, not here. So a second. So also give me a second. This problem also can be interpreted. This example also can be interpreted as practical significance, because you see that 52,000 out of 10,000, so it means that 52%, right? So that's the what's the normally the probability that what the couple gonna have uh, the girl is gonna be just 50%, but okay, so but 52%, this slightly just only 2%, then they're not gonna spend the money to increase the the likelihood of the girl from 50 to 52%, right? So that problems so can also example of practical significance, right? So the move to the original problem. So we're going to calculate the test statistic and the p-value, right? So we go to the stack and then test, and we use t-test, right? So, and then we use stack mu 0 was 0, right? And then x bar, which is sample mean, is a 3, and then sample standard deviation is 4.9, and then sample size is 40. Okay, and then the h sub 1 is mu is greater than 0, which is original uh, claim. So we draw it. Okay. So we see p is really small. It's a 10 to the -4, right? So r by 0.01, right? So what that means? I mean, yeah. So since the p-value is just left tail test, okay? So p is less than alpha, so we will reject the h sub 0, right? And then h sub 1 is the original claim, right? Okay, so we second case, there is sufficient evidence to support, okay, the claim that what the mean weight loss is greater than uh, the 0. Okay, so now but I think give me a second. So yeah, but I think this is a not greater than, I think a point. Um, I think a point. Let me change the problem slightly. 0.2. Okay, so it should be 0.2, 0.2, and then 0.2 and 0.2. Okay, let me change this the mu to 0.2. So let me change the problems. Stack test and t-test. This is 0.2. Okay, change it. I just changed the mu sub 0 to 0.2. So I just change the claim, modify the claim. The mean weight loss is greater than 0.2 pound. Okay, calculate. Then I got this. Still, p is really small, right? P-value is really small. So then still we reject the h sub 0. Okay, and then h sub 1 is a claim. So there is sufficient evidence to support the claim that the mean weight loss is greater than 0.2. But what can you say about this? Is that so? Actually, what this is the um what practical significance, right? So I mean, what? So definitely they're not gonna spend the same problems as previous problems. I mean, the people normally don't pay spend money to lose weight to 0.2 pounds, right? So that's the practical example of practical significance. Okay. Yeah, so in this video, I just cover 8.2 and 8.3, and the other problems what I don't solve, I'll do the next time. Okay, for example, this example, they just instead of the sample statistic, sample data is given, right? So then we just enter the data into the calculator, and then we use it, and then we use the t-test, we can figure out the conclusion about the claim, right? So I'll just cover this one next time, okay? And then also I'm going to cover the chapter 9 next time, okay? So let me stop here.